All right, welcome back everybody to our second lesson of geometry. This is Unit 1, Lesson 2. I am the Math Patriot, aka Mr. Love, coming to you live from my class today. We are going to be working on points, lines, planes, just like last class period, but we're also going to be moving on and doing some bigger and better things. Now, last time we talked a lot about how points, lines, planes, that sort of stuff are kind of abstract. They don't really exist in reality. Space is big, but technically endless. So depending on which definition you use, which physicist you're listening to, whether or not the universe has a boundary determines whether or not outer space qualifies as a geometric space. Also, lines, while lines geometrically, they extend on and on in both directions. That doesn't really exist in reality. There's nothing that actually extends both directions forever. The closest we have to that is like a ray of light, but even then it doesn't go both directions, okay? Because the ray of light starts at one point and then goes on infinitely in one direction, not in both, so therefore it's not technically a line, okay? So in order to actually do stuff, we have to start breaking down lines into smaller chunks. And that's what we're going to be focusing on today, is what to do with these things, chunks of lines called line segments, okay? Now, let's talk about what a line segment is and how we write it, okay? If you had a line, and we had line AB, again, the arrows indicate that it goes on and on forever in both directions. Now, if we wanted to talk about just the piece that started at A and ended at B, that would be a line segment. We would call this segment AB, and the symbol for segment is the bar above the cross with no arrows on it. Indicates it stops at A and B. Now for a line, we had an infinite number of names. However, for a segment, we have to only name it by the endpoints themselves. It is going to be either AB or BA, and that is it. Even if there's a point C in the middle, we cannot call it AC. We can't call it BC. It's only the two endpoints A and B. Okay? Now, as far as what we actually do with that, let's take this exact same picture over here, A, C, and B. The beauty of line segments is they have measures. And we can add those measures together to get from two smaller segments to a bigger one. So, for example, if we had AC plus CB, which notice AC is the left side, CB is the right side. The left side plus the right side is the whole thing. That's going to equal AB. Now notice on these, I did not use a bar above it. There is no line symbol on it. When you see 2 points listed without a bar above it, that's referring specifically to the measure of or the distance between them. So anytime that, we're going to make sure that we're being careful with our symbology here. Okay, put the 2 lines on the symbol if you're talking about a line. Put 1 line on it, put no arrows on it if you're talking about a segment. And then no symbol at all if you're talking about just the distance between them, okay? Now, let's just say, for example, this guy was 2 and this one was 1. Well, how far is it going to be from A to B? Well, that's 2 plus 1 is 3, okay? That's all a line segment addition is, all right? So, let's go down here and do our first example, which I had you guys circle on your sheet before we started. Okay, we want to find the distance from A to C. So, all we're going to do, 4.9 plus 5.2. And help me out. What's 4.9 plus 5.2? 10.1. 10.1. My calculator's not want to turn on over here. Ah, there it goes. All right, 10.1. All right, easy enough. 10.1. Okay. However, what about if I give you the whole distance and I'm asking you to find a shorter one? Okay, so here I want you to find GH. What am I going to do?
Subtract.
Yeah, we're going to subtract them instead of add them. Okay? So, all we do is, okay, I'm going to overkill the algebra here for a second. I realize you probably wouldn't have to write this all the way out. I just want to write it out in case you need it for something later on. Technically, we've got FG plus GH, the left side plus the right side equals the whole thing FH. So then when I go to plug all that in, FG is 9.7. FH, the whole thing is 15. But this thing, GH, we don't know. And instead of assigning it a single letter variable like you're used to doing in algebra, in geometry, it's okay for us to use the names of objects as variables, have multi-letter variables. So it's okay for me to just leave this GH here. The reason we do that, the power of what it gives me is that I don't have to worry about like questioning later on what is X. There's a big problem that you got a lot in your algebra classes is does X stand for the rate of the cheese production or the speed of the car? And you kind of forget what X and Y are. Okay, if we leave the name of it in there, we don't have to worry about that. GH is always just the distance from G to H. Okay? Now, that being said, solving this equation, how do I solve for GH?
Subtract 9.7 from 15.
Yeah, just subtract 9.7 on both sides, and you're going to get GH is
5.3.
yeah, I should have believed y'all. 5.3. And let's make sure we leave our units on there. So it's 5.3 millimeters. And I forgot my unit on the first one. It should be 10.1 centimeters. All right, any questions over that?
No.
All right, easy enough. Now, on this one, we don't have... Yes, sir.
Did I leave my water bottle in here?
I have no idea. You can look if you want to. All right, so if we don't have a picture and we still get this whole between thing, okay? This word between literally means that all of those 3 points are in a straight line. They're all collinear, okay? Just like we talked about last class period. Now, so y is between x and z. I'm going to put x and z, my 2 points there, and then y is there in the middle. All right, so now we're going to start plugging stuff in. xy is 5x. yz is x. And then xz, this whole thing is 25. Now, does anybody see an equation we're going to make out of that? It's very similar to the one with just numbers. We're just going to plug it in the same way, though. Anybody see it?
Wait, I have a question.
Yes, ma'am.
How did you get 3x?
That's a 5. It's just bad handwriting. She asked, how did I get 3x? That's a 5. Does that look better?
Yeah.
All right. Okay, equation. Left side plus right side equals whole. What's that going to come out to? We're going to write the equation, though. So what's the left side?
5x.
5x plus right side? X equals whole is 25. Boom. Okay, now we solve. My first solving step?
Subtract.
We could subtract. I like to combine like terms first. I mean, if you're going to subtract stuff out, but all my x's are already on one side, my number's on the other, so my best option is going to be just combine like terms. So 5x plus x is 6x equals 25. And now how do we get x by itself? We're going to divide by 6. So then 25 divided by 6 is 4.16 repeating. Now, I want to go ahead and mention this because this is our first time in my class to have a decimal that was longer than 2 digits. Everything we do in here, we're going to round to 2 digits. Notice I said round, not just cut it off. Okay? So go in, look at the second digit, and then peek at the third. That 6, is it round up or down? Up. So we're going to have 4.17. That's my value of x. All right. Next up. same idea as above. X, Y, Z. XY is 2x plus 1. YZ is 6x. And the whole thing is 81. All right, anybody want to take a stab at this equation? Okay, 2x plus 1. 6x equals. Perfect. All right. Combine like terms, yes. 2x plus 6x is 8x. Plus 1 equals 81. And now, subtract 1 gives me 8x equals 80. Divide through by 8 gives me x equals 10. Which part? Okay, so right here, the 2x plus 6x became 8x. The 1 just dropped down to there. Okay, then we're going to subtract 1 on both sides. So if I subtract 1 here and subtract 1 here, 81 minus 1 becomes 80, and that guy goes away. Then we're going to divide both sides by 8. 80 divided by 8 is 10. Sorry, I never know where my students' algebra skills are coming in. So I tend to assume that everybody just knows how to do this stuff, and I forget that not everybody's algebra skills are the best. That's fine. We're going to work on them throughout the year. We want to not just preserve, but also improve your algebra skills so that next year when you go into Algebra 2, you'll be all good to go, ready and caught up. All right, next up, distance on a number line. Okay, now this is going to be very similar to, honestly, what you did back in like kindergarten. Okay, when, like, if I wanted to find the distance between like L and M in kindergarten, I mean, didn't we like used to do stuff like this, like 1 bunny hop, 2 bunny hop, 3 bunny hop? The distance is 3. Did y'all do that sort of stuff? Yeah. I love that. That was back in the day, right? When everything was nice and easy. But like any good math teacher, I got to overcomplicate things. I said for example. Okay. Now, here's how you're going to do it. All you're going to do to find your distance, I'm going to use D for distance, is just x2 minus x1. And x2 is going to specifically be the bigger one here. Okay? So the bigger one. So, just subtract them. All right, so Ln. Which one's bigger, L or N? N. N. Where is N?
9.
9 minus L is... Wait, L is at where? 3?
3.
So the answer is 6. Okay? JL. Which one's bigger, J or L? L. So L is at 3, which we already did that. Minus J is... Now, watch what I do here, guys. Seriously, watch this. I know that our adding and subtracting of negative numbers is not the best, okay? When you're plugging in a negative number into a formula, watch what I do with this negative sign, okay? L is at -5. I'm going to write, since I already have a minus sign right there, I'm going to write my negative here. Because minus and negative is a plus. That way I just go ahead and combine it in. I don't have to worry about doing those rules. It's just 3 plus 5. And then my answer is 8. All right. Do we need to do the other 2 examples, or y'all think y'all are good on that?
I don't get that at all.
With the whole, which part? The minus negative thing or the distance thing?
No, the minus negative.
Okay, so here's what it is. If I was to write it out the long way, I would have had 3 minus -5. Well, so yeah, L was 3, which is that number. I use the bigger one first, regardless of which one it is. The bigger one goes first, because all my distances in geometry need to be positive. And so if I did it the other way, I would have got a negative number, and then it would have thrown things off.
So for like number 13, like 9 to it's -2 or -2.
Wait, which one, KN or MN?
Yeah, KN.
So KN, yeah, so I've got, let me erase this. I've got K right here and N right here. So I'm just going to pick the bigger one to do it first. Even though K is listed first, I'm going to do N first.
9 plus.
Yeah, so it'll be 9 minus -2, which is +2. Just put the larger one first, and then you don't have to worry about the negatives. All right. Now, distance on a coordinate plane. This gets a bit more complicated. Okay? Here's our distance formula when we're talking about coordinate planes. Now, we're going to have 2 points, and we want to find the distance between them. This point up here is going to be x1, y1, and this point down here is going to be x2, y2. Just like you had back in Algebra 1 doing slope formula. x1, y1, x2, y2. Okay. Your formula is the square root of, and I'm going to go ahead and scaffold this whole thing out so I can do my colors in it. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. Now that formula is actually not quite as scary as it looks as long as you do it one small step at a time. So for our first example here, I'm going to go ahead and label these guys. Let me make my pen a little bit smaller here. X1, Y1, and then X2, Y2. Sir? Yeah. Go ahead. All right, so whenever I start plugging these guys in, x2 is 4, came from right here. X1 is 2, which came from K. Y2 is 4, came from my F point. And then Y1 is 3, which came from my K. All right, now let's simplify inside the parentheses first. 4 minus 2 is 2 squared plus 4 minus 3 is 1 squared. And now we're going to do our squaring. 2 squared is 4, plus 1 squared is 1. And now that gives me 5. And now, I don't need that square root symbol anymore. Let's run to the calculator on that. Square root of 5.
2.24.
Why is that doing that? I think that's right. 2.24. Yeah, 2.236 rounds up to 2.24. Okay. Any questions on that? You good?
Wait,
Yes.
can you explain where we got our numbers Where's 4 again? Oh, never mind, I get it.
Wait.
X1, Y1, X2, Y2.
Yeah, that's why I was trying to color code them so it's easier to see. Okay. All right, next one. X1, Y1, X2, Y2. D equals squared plus squared. Also, notice how I'm setting up the pattern first before I plug stuff in. That's one of the ways that I do it to help me not make mistakes later on. Okay, I make fewer mistakes plugging in whenever I set the whole problem up first. All right, so x2 minus x1. x2 is -2 minus, and then I'm going to do that whole thing with the plus. -3 becomes +3, minus -3 becomes +3. Y2 is 3, and Y1 becomes minus -1 becomes +1. Oh, and I forgot my equal mark here. All right, any questions on plugging that in? All right, so let's simplify. Inside first, -2 plus 3. 1. 3 plus 1 is 4. 1 squared is 1, plus 4 squared is 16. 1 plus 16 is 17. Square root of 17 is 4.123, which is 4.12. Yes, ma'am.
I might be wrong, or I might have written it down wrong, but didn't you separate with the parentheses X and Y different on the last one?
Did I make a mistake on separating them?
For the last one, I think.
Okay, let's see.
I might have written it.
What are you talking about, like doing this section here?
Because on number 15, at least I wrote it down that way, you put X1 and then X2 and then Y1 and Y2.
So here I did
Or
this
you did
one
2 Ys, that's what it was.
there, -2. That one was in the right spot.
That's why your X looks like a Y to me.
All right here.
Yeah,
Sorry, yeah.
it's fine.
Yeah, my handwriting stings. And getting used to writing on this tablet. Okay. All right. So, that's it for today. I'm going to go ahead and cut off the video. All you guys who are watching on YouTube, feel free to go on to the next video in the playlist as soon as I get it up. And as always, guys, enjoy you doing your geometry and stay patriotic.